Hi everyone, welcome to Leetcode Biweekly Contest 76. Wish me luck. Alright, let's go. Alright. Take it by X. Part or all. Nine one. AC. Okay. $20, $50, $100. Min self. Otherwise, fine. Turn rest. Alright, please. AC. Okay, I need a path. Of length specifically 4. Okay, I can do this. So let's get schools. Shan. Okay, so I need an adjacency list. All right, let's just do that. J I if score of J greater than equal to. -1. B by 0. Int object is not subscript. Oh. Variable name duplication. What? Oh. $28. Why is that giving 28? You can't even get 28, so. Oh, okay, I see. I think I need to think about this a bit. So for each node, I need to store them. I'm going to store 4 times the amount, I think. Huh? Where did this go? So JJ plus B plus B. $36. Let's copy paste that again. Oh. Okay, this is falling apart. Please don't tell me. What? Alright, let's print out B. Um, Oh, okay. I have to find my thing the wrong way around. I need plus ones here. Alright. 24, -1. Don't TLE. Okay, thank you. I was very worried about Python right there. Let's have a look. Okay, so I did get 1504, which right now is going to put me in... Oh, this includes the China. So right now I'm actually in third, but we'll see how it turns out afterwards. The leaderboard's probably going to refresh. Anyway, that was a very slow Q4. I actually had a good Q1 to 3, but I choked the fourth one as usual. Yeah, this guy beat me as well. Okay. So for this question, it's pretty simple. You just iterate. So what I did was, I'm sorting the list. First, I'm sorting the list by its absolute value, because the number closest to 0, that's its absolute value. Like absolute value of x returns x if x is positive and negative x otherwise. So that's exactly what we want. So abs x is the distance to 0. So I'm first sorting it by its absolute value, and then if there's ties, I'm going to tie break it. I use negative x here, so that will give me the largest value first. I didn't actually need to use sort. I could have I probably could have used min as well. I can just find the minimum element based on this comparator, and that will probably work as well. Right? Then there's this question. Basically, the main idea is I can brute force over all ways to buy a pen. So there's only up to 10 to the 6 or 10 to the 6 plus 1 a different number of pens I can buy. Because obviously I can't buy more than 10 to the 6 pens, because otherwise that would cost at least more than total. Which means I'm brute forcing this I variable. This I is the amount of money I'm going to spend on pens. And I can show, and this loop is only going to run at most 10 to the 6 times. Worst case, because 10 to the 6 plus 1 times, because that's the because I is 0, total is up to 10 to the 6th, and cost one's at least 1, so this will run at most 10 to the 6 plus 1 times. Then for each number of times I buy a pen, I need to figure out how many pencils I can buy. I think it's easier to do this with an example. So let's say I have $10. Let's say cost 1 equals 3, cost 2 equals 2. Make that $11. And let's say I'm buying $6 spent on pens. That means I have 11 take 6, which is $5 left over for the pencils. And now my question is, how many different number of pencils can I buy with $5 if the price of one pencil is $2? So I could buy 0 pencils, I could buy 1 pencil, I could buy 2 pencils, and that's it. Any more number of pencils would be too much. So how do I find the maximum number of pencils I can buy? Well, the maximum number of pencils I can buy is just the floor of 5 divided by 2. And then once I've figured out, that will give me this value of 2. And then the number of pencils I can buy is simply 1 more than this quotient, because I can buy 0 pencils as well. So for each amount of money I spent on a pens, I work out the remaining money I have, divide that by the cost of a pencil, and then I add 1 for the 0. And yeah, since this loop only executes 10 to the 6 times, it's good enough. Okay, this question is there's nothing to it. You literally just simulate what it is. So I have an array self.a, which is exactly how they've done theirs. Like the first element in this array will be the number of $20 notes I have. The the next element will be the number of $50 notes, and so on. So I'll have 5 of these values. To deposit numbers, I simply increment the corresponding counts. And then here I just simulate the answer. So I can't simulate removing one note at a time, but what I can do is I can say, when I get to this withdraw function, I can say, how many $500 notes am I going to withdraw? And then once I've worked out how many 500 notes I'm going to return, I'll just subtract that amount of money from this amount, and then I'll keep going. I'll say, how many $200 notes am I going to withdraw? And I'm going to keep doing this. So basically, these are the amounts. I'm going to loop backwards in decreasing order of amount. Each time, how many notes of that type am I going to withdraw? Well, on one hand, it has to be bounded by the number of notes I have. I can't withdraw more notes than the bank actually has. And on the other hand, it's also bounded by this, because if I withdrew more notes than this quotient, then I'd be withdrawing too much money, and that doesn't work. So for example, if amount was 60 and I'm withdrawing a $20 note, 60 divided by 20, that's 3 notes. So once I figured out how many notes of that type I'm going to take, I'm going to update this, and I'm going to subtract that off my remaining amount. If I have amounts left over, that means I wasn't able to withdraw exactly that amount of money, so I'll return -1. If it is possible, then I have to actually update my bank, and then I'll return the answer. It's pretty simple. Yeah. So then there's this problem which I spent way too long on. Okay, so we need to find, so basically we have some graph, and I need to find, of all paths of length 4, which of them has the maximal sum of the scores of its nodes. And I'm lucky because I actually set a contest with this idea recently. But anyway, the main idea is if you want to loop over 4 nodes, it's pretty easy to loop over the middle 2 nodes, because the middle 2 nodes is going to correspond to one of the edges in the graph. So for each path, so if I loop over all possible sets of middle nodes, that's just looping over all possible edges in the graph. Now, let's say I'm going to say that the optimal path out of its 4 nodes, the middle 2 nodes will be these 2 nodes. Let's say I'm fixing those nodes. And then what's the maximum score I can get? Well, it will simply be if I can pre-compute for each node, what's the maximum value of a node which is adjacent to it? So the maximum score of a node adjacent to a 1 here is 5, and the maximum score of a node adjacent to this node is 8. So when I get to my loop, when I loop over this 1 and 2 as the middle values, I will simply take the scores of this value plus the score of this value plus the 2 pre-computed maximum values, and that will give me that path of length 4. So you might notice this doesn't look quite as nice as that, and yeah, that's because it's not that simple. That there are more cases. For starters, when I let's say, for example, that I was looping over 0 and 1 as my middle 2 edges. If I loop over 0 and 1, this doesn't quite work because my pre-computed maximum value, actually it might work. Yeah, it would work in this case, but sometimes, let's say, ignore the values that they gave here. Let's say I looped over these 2 middle nodes, and the maximum score of a node adjacent to this one happens to be this node as well. So this is a middle node, and this is a middle node, and we're trying to find the other 2 outer nodes, but the pre-computed node with the maximum score adjacent to this one is this 2. And my path isn't allowed to have this 2 again, so I can't actually do that. In this case, if the maximum score of a node adjacent to this one happens to be this node, then I'll take the node adjacent to the one with the second largest score, which happens to be this node. Yeah. Or I hope I'm not doing that wrong. Yeah, so it would be this node. And yeah, similarly, if these are my two middle nodes, and the node with the largest score adjacent to this 2 happen to be this node, I would instead have to choose the second largest node, which is actually this 3. And that's where we run into our another complication, which is, so if we pick these two middle nodes, and they both happen to pick this 3, we can't have that because we can't have duplicated values. So that's another case which we're not allowed to have. We might accidentally form a cycle of length 3 instead of a path of length 4. So instead of just pre-computing for each node what is the first and second, what are the two nodes with the largest scores adjacent to it, you need to pre-compute 3 nodes. And actually I pre-computed 4 nodes just to be safe. I'm not entirely sure if you need 4 nodes, but basically, yeah, I played it safe. I'm not sure if 3 is good enough, but for each node, I'm pre-computing the 4 nodes adjacent to it with the largest scores, and this is all the pre-computation work. Then, I'm looping over I and j, which I and j will be my middle 2 nodes of the path. And remember that those 2 middle nodes correspond to an edge in the graph, so it's easy to iterate over them. Then, for each of these 2 middle nodes, I will try all of the pre-computed maximum, highest scoring nodes adjacent to them. If those nodes exist and none of the nodes are equal to each other, then I'll try to update my I'll update my answer with the current score of the path. So that's the crux of the algorithm. The only thing left to do is how do we pre-compute for each node what are the 4 nodes with the highest scores adjacent to it. It's actually pretty easy. So I have this array which is of length 8. The way I've defined it is this element will be the and let's just consider one row. So bi is going to have 6 values, and this is like bi will be like the maximum scoring nodes adjacent to node I. I will have 8 values. The first value will be the maximum score of any adjacent node to I, and then b will be which node gives this maximum score of a. Then c will be what is the second highest what is the second highest score of a node adjacent to I, and d will be the node corresponding to that value. Then e will be my third highest score, and g will be my fourth highest score. So that's how I've defined it. Then for each node, I'm going to iterate through its neighbors, and I'm going to try to update this bi. If the current score is better than all scores I've seen so far, like let's say this table has been like partially filled and I come across an extremely high scoring node. Let's say I have a node with a score of 1000 and that node is 1. So let's say I come across a node with a score, this node 1 with a score of 1000. I need to update this bi. So the way I would do this is I would update this to be 1001 ABC DEF. Basically, our new top spot is taken by this node, and then I will shift the best nodes we've seen down, and they will become, so like the best node that we had previously, that will now become the second highest scoring node that we've seen so far, because our new node will be better than that. So we need to shift everything down. So what if our node is not higher than the best scoring node, but it is higher than the second highest scoring node? Well, in that case, I would insert my things here. The best node is untouched. I insert my current node as the second best node we've seen so far, and then I'll shift down the remaining ones. And I can do that for the third best and the fourth best nodes as well. So that's how I pre-compute this table. Okay, so what's the complexity of this algorithm? I don't know what I did. What's the complexity of this? Well, since adjacency of I, that can have a length up to n. So you might think that this algorithm is n squared, but you have to remember that I and j, when we loop over it like this, that's actually corresponding to an edge in the graph, and there are only at most 50,000 edges. So this will only have 50,000 iterations in total. And then similarly, this will have 50,000 iterations times a constant number, which is 16. So in fact, the complexity of this is just proportional to the number of edges, which is fine. Anyway, yep, that's all I have. Let's see how I turned out. Oh, looks like I only got rank 12, which that could probably be losing me rating. Last time I got rank 15 and I lost rating, so we'll see. Anyway, that's all I have for you today. Hopefully I'll do better in the next weekly, and I'll see you guys later.